Hello. Welcome. Thank you for seeing us. Rudolf Tansi is your name?
Yes.
And your name is, of course, Deepak Chopra.
Yes.
I have some questions for you regarding Alzheimer's. You have some unorthodox ideas. I'm looking at you, Deepak Chopra. You have some unorthodox ideas about Alzheimer's. Can you tell us a bit more about that?
Well, according to geneticists like Rudy Tanzi and others, only 5% or less of the genes that are associated with Alzheimer's disease are fully penetrant. So there are 5% or less 5% or less disease-related gene mutations that are fully penetrant. Means you can't prevent them at this point of our knowledge of them. The rest could be influenced by lifestyle. Before I even go further, am I quoting you accurately on that?
Yeah, it's a matter of lifespan. So my lab discovered the first Alzheimer's genes back in the 80s and 90s, and most of the mutations we found in those first genes caused early onset Alzheimer's, under 60 years old, guaranteed disease. Many of the other new variations in the genome we're finding for Alzheimer's increase susceptibility, but don't guarantee the disease, at least in the time of a normal lifespan. But we don't know if we start living till 110 or 120, whether some mutations that look like they only increase susceptibility may guarantee disease by 120. But we always have to think about genetics with regard to how long we live. And right now, as Deepak says, 5% of the mutations we find for disease genes guarantee the disease. The other 95% so far look more like risk factors, giving us hope that there's something we can do about it with our lifestyle.
So based on that, I've been saying for a while that good sleep, meditation, exercise, but in that I personally include yoga and breathing exercises, but also aerobic exercise, emotions, and food. These are the 5 things that we can actually influence. And we now know from a number of studies that these 5 things, including deep sleep, delta sleep, influence how amyloid is deposited in the brain. And maybe I'll let Rudy comment on delta sleep and amyloid in the brain.
Sure. So my lab discovered the amyloid gene long ago, and we've been studying how amyloid deposits in the brain. And we now know that just about everything you do in your lifestyle affects the amount of amyloid you have in your brain. During deep sleep or delta wave sleep, you actually clear amyloid out of the brain. You also make new stem cells in the short-term area of the brain, which is affected most in Alzheimer's. We know that diet affects amyloid levels. We know that staying socially engaged, intellectually stimulated is very important. So in just about all the things we do, even meditate, we're affecting our amyloid levels. And why that's so important is that amyloid triggers this disease. It's the match that lights the fire. If you stop the amyloid, then you'll nip the disease in the bud. So all we can do, just like we monitor our cholesterol, we keep it down, we need to do the same for amyloid when it comes to Alzheimer's disease.
But it takes several decades for Alzheimer's to actually manifest as the disease. It's not a magic bullet that, I start meditation today, I cleared the amyloid. On the other hand, based on what we know, I think the vast majority of people who are diagnosed with amyloid could actually, or Alzheimer's, could actually influence that disease unless they plan to live for 120 years, in which case they might get it. We're not sure. I'll tell you when I get there.
But how can they influence it?
As I said, through lifestyle changes that include sleep, meditation, stress management, exercise, healthy emotions like love, compassion, joy, equanimity, instead of hostility, anger, guilt, shame, all of which increase adrenaline, we know, and cause inflammation in the body. Inflammation is a big thing right now as a background. And of course, now we're learning that even our microbiome responds to our mental states. And the microbiome produces peptides like serotonin, oxytocin, dopamine, which happen to be immunomodulators. They fine-tune the immune system. So I think instead of thinking just one thing, amyloid is a marker for this disease as well as something that accumulates. But we have to start looking.
It causes the disease.
It causes the disease.
It's not just a marker.
Okay, it causes the disease. But
we used to think it was a marker, but now our new study from last year, the Alzheimer's in a Dish study, that for which we won the American Ingenuity Award this year, and it's changed the field. We now have direct proof by, for the first time, recreating Alzheimer's in a dish with human stem cell derived nerve cells. We can say amyloid causes this disease, and so I'm very sensitive about using the word marker, because we used to think it was a marker, but it's actually the cause.
It's the cause, but the cause is multifactorial in the deeper.
It's multifactorial
factor.
Because you have to ask, okay, amyloid's causing these what are called tangles to form in the nerve cells die, and then there's inflammation, and then there's more tangles and more amyloid. You get a vicious cycle. So the big question is, what makes amyloid accumulate in the brain? We know in those 5% of cases, mutations that guarantee amyloid. Doesn't matter how you live your life. But we also know, like Deepak is saying, it's multifactorial, that another way to accumulate amyloid in the brain is infection. So this is a new study we've been doing for the last 5 years, where we see that infection in the brain, bacteria, herpes virus, yeast, the amyloid is a natural protective agent against microbial infection in the brain. So you may have infections that have no symptoms, that don't cause encephalitis or any type of physical ailment, but it's chronically causing the brain to make more amyloid to fight the infection. And that amyloid is well intended. But now, if there's too much amyloid, this triggers the disease process. This is now what we're learning. So this becomes very, very multifactorial. And now lifestyle becomes even a bigger part of it. Because, you know, whether infection gets into your brain depends on how tight your blood-brain barrier is. That's going to be affected by your vascular health, your neurovascular health. Are you having mini strokes? So,
which is affected by diet and exercise
and stress.
Right. So it's you know, you have to start thinking of the body as a unified process in which all these things are involved, and even genes are actually the activities, the localized activity of the unified process. Genes are verbs.
Well, genes are actions. Yes.
Yes.
Yeah. It's all action.
But okay, so you're talking about lifestyle, but what can doctors do? What can medicine do?
I think medicine has to take on a role of education also. And if doctors can't do it, then healthcare providers should do it. Doctors are busy these days writing prescriptions, and it's difficult to break that habit for them. But they can have people in their offices who provide education. That's, you know, I did that when I was a practicing physician in Massachusetts. I used to tell my patients, listen, you can't sleep, you have high blood pressure, you're stressed. I can give you a diuretic and I can give you a tranquilizer. Or if you want to try something else, I'm giving a lecture on Friday. And before I knew, there were hundreds of people coming to the lecture on Friday and saying, I want to try that instead of taking a diuretic and an antihypertensive, which has side effects. And, you know, most people who are hypertensive, they're minor elevations. But over years, those minor elevations build up to everything that we call disease.
But if you want to talk about drugs that are on the horizon, we now know that hitting amyloid must happen very early. Amyloid accumulates in the brain 15 to 20 years, maybe even more, before symptoms. The mistake we've made with drug trials, that either try to stop the production of the amyloid or clear it out of the brain has been we're treating full-blown patients. It's like having a patient with congestive heart failure and a heart attack, and you say, here, just take a statin, like a Lipitor. You had to do that 15 years ago. We only learned that recently. So now I have drugs that are in trials that are stopping the production of the amyloid. We have other drugs with an Australian company I work with called Prana that gets the amyloid out of the brain. We're using Ayurvedic supplements like ashwagandha, right? I mean, how long have Indians been chewing
Thousands of years.
roots, ashwagandha root? We now know that ashwagandha, actually, you know the mechanism of how ashwagandha helps get amyloid out of the brain and clear it out. We're using Peruvian herbs like cat's claw, which can actually break apart the amyloid. So we'll try anything, not just conventional medicinal drugs that we have in trials, but also, if we can put good science behind it, Ayurvedic herbs and other types of supplements that have been used for a long time by various cultures to stave off senility.
So also in Ayurveda, there are things like amlaki, embolica, myrobalan, ginger, garlic, curcumin. Some of these don't cross the blood-brain barrier, but they definitely decrease inflammation. So indirectly, by decreasing inflammation, they may be affecting Alzheimer's.
Yeah, inflammation is the killer, because inflammation in your body will translate to inflammation in the brain. Your bacterial load, your microbiome of your gut, directly affects inflammation. There's a paper coming out any day now in Nature Neuroscience showing definitive evidence that your gut microbiome is directly determining the amount of inflammation induced by microglia in the brain. Microglial cells are double-edged swords. These are the guys, microglial cells are normally helping you out. They're cleaning up the brain. But when things go wrong, when they see a lot of dead nerve cells, like in Alzheimer's, they assume an infection. So now amyloid goes up, they're shooting out free radicals, they're creating inflammation. And again, they think they're doing well. They think they're killing off an infection, but it's the collateral damage, the friendly fire. They will kill many more nerve cells than the original amyloid entangled pathology. So inflammation is the #1 enemy you have to hit.
There are two other recent papers that actually bring attention to some of the things we're saying. One is that when you have increased vagal tone, which means your parasympathetic nervous system is dominating your sympathetic nervous system. When you're stressed, it's your sympathetic nervous system. But when you have increased vagal tone, the vagus is a nerve that goes from the midbrain right to every part of the gut. And it's called vagus. The English word vagabond comes from vagus. It's the wandering nerve. If you increase vagal tone through electrical stimulation, it changes the behavior of the microbiome. It increases the peptides I mentioned, serotonin, etc. And it decreases inflammation. That I just saw a new paper. But then I looked up the things that we do with yoga asanas, with breathing techniques, with meditation, all of which increase vagal tone. So there are pharmaceutical ways and there are non-pharmaceutical ways of decreasing inflammation as well. And then I don't know what the implications of this other paper are, which shows that the brain has a very extensive lymphatic system, and therefore there's a direct connection between what's happening in the brain and what's happening in the immune system. You want to say anything about that?
Well, this was a stunning discovery. I mean, dogma has been for centuries that there's no lymphatic system in the brain. And the first step was to find that microglial cells help get rid of junk in the brain while you sleep. In deep sleep, the brain condenses and helps clear material. It was being called the glymphatic system because it's glial cells. But now a paper came out that said, yeah, that's fine. But actually there is a lymphatic system. A lymphatic clearance channel was found in the middle of the brain that had never been seen before, but thanks to modern brain mapping techniques, it was uncovered in a very simple way. And the paper just came out and it's rocked the entire world because, this is completely against dogma. It's always been assumed that the brain doesn't have its own lymphatic system. That means the brain is connected to the rest of the brain's lymphatic system for immune protection and for clearing toxic debris before it causes disease.
So now we go a little one step further. It says that the brain, the immune system are connected, but so is the endocrine system, because the endocrine system, the peptides we mentioned, they're also immunomodulators. And the endocrine system is affected by your emotions. So we once again have this mind, brain, genome, epigenome, microbiome integration, because the body is once again an integrated process. And the more we start to look at these connections, the more we'll have multiple ways of addressing the amyloid accumulation. Some pharmaceutical, some maybe electrical, as we're seeing, or some based on mind-body techniques that have been present for thousands of years, some on the herbs that are found in these traditions, which are known as adaptogens.
So this is why in my own lab at Mass General Hospital and Harvard, I like to hire 50-50 the reductionists, people who can really tear apart the leaf and see what it's made of, and 50% people who can look at the forest. Because to do science, you have to be a reductionist and tear down things to its smallest parts. But you have to then know that those parts only matter working as a whole, and even systems working together. And you don't really get the full answers until you do both in science. And for too long, science has only focused on reductionist methods and have not taken time to look at the whole. And if you look at the whole and you're holistic, people will make fun of you. But now we're learning that if you don't look at systems as a whole, you don't get the answer. So systems biology and network analysis, deep machine learning to look at big systems, gene-gene interactions, systems interactions is absolutely essential.
And mind-brain interactions, right?
Well, we have to wait for them to get there, but they'll get there too.
They'll get there.
We just have to keep pushing that.
But do you understand there's a lot of people who criticize your ideas? Do you understand that?
I think they're a little 30 years late, by the way, that they haven't kept up with the science. They're frozen in an obsolete worldview. And to be really honest, we can't change their opinions. They say that paradigm shifts happen one funeral at a time.
Yeah. You know, most sleep is very deep, and it's very hard to wake up. You know, if you look in historical records of people in science who have been criticized, we're in very good company. Galileo, many others, okay? What you have to do is be willing to think openly. I tell my students this: be willing to think openly, and don't be afraid to freely associate. Use your synaptic energy, use your synaptic power to come up with new possibilities. But when you go into the lab, your only job is to show you're wrong. That's what scientists do. A scientist has to come up with their best possible idea, hypothesis, and their job at the lab bench is to prove they're wrong. If you're not doing that, you're not doing science. So this is the yin and yang. You can be open-minded, but remember, you need to back it up with good science, and good science is always trying to prove you're wrong. And what happens when you do this is that you just get little threads of truth, little threads. And over time, you weave a tapestry of truth. And if you can leave this planet as a scientist with one small swatch of tapestry of truth, the last 50 years, you've done more than most.
Well, thank you.